Google just released a really important tool for data scientists to use for free. Google released its marketing mix model called Meridian to be open source to the public. And if you're not familiar with marketing mix models, you really should know what they are because they are like the holy grail for your marketing stakeholders. Here's the idea behind a marketing mix model. Let's say you're this big company and you advertise on a lot of different channels, such as TV ads, Facebook ads, YouTube ads, search right on Google, like all these different channels. And you can imagine one person may see multiple of your ads in all these different places. They may stumble on a TikTok ad, then they may see a Facebook ad, then they may see an advertisement on TV or on a billboard in the street if you're, let's say, a big company like an Apple or a Samsung. So companies are spending ads in all these different places at the same time. And then when bookings come in, they want to know how much of the ads from each one of these channels is driving new customers. So the idea behind a marketing mix model is you would have this time series of all your bookings, maybe by region or nationally. And in the other columns, you would have the amount of spend or the amount of impressions that you had in all of these other channels. The model then attempts to identify how many of your conversions are organic, kind of baseline conversions, how many are attributed to marketing as a whole, and how many are attributed to each one of those individual channels. And if you're familiar with linear regression and multicolinearity, you should know that this is a big problem or a difficult problem to solve. And it's actually not just a multicollinearity issue, but there's also the endogeneity. So the fact that marketers usually will spend more where they expect demand is, and all these could bias estimates. So Google put together this dummy data and they allow you to install their Meridian package. They tell you the packages you need to import. Then it assigns or then you would define which of your variables in your data sets are the different media, like let's say the impressions or clicks if you're using that. It would also, you would define which are your spend variables. This helps you calculate ROI. And then it has a simulated data set that you can use, assign some priors, and then you run the model, and that's it. And then it gives you all this output, right? So here are your expected versus actual bookings. You really can't see because they're almost right on top of each other. But of course, this is problematic. I mean, this is like an in-sample prediction. So you would generally expect that the actuals versus the expecteds are very close because this is all in sample. So, but essentially this is saying the orange line are your baseline bookings, the blue line are your actual or expected bookings. Again, they're right on top of each other. And the gap between them are your bookings that are driven by your marketing activities. They give you some model fit metrics. In this case, it shows that the MAPE is 1%. So that's the mean average percent error. But again, this is all in sample predictions. And now this is what is the dream sort of result for marketing professionals. They want to know where the bookings are coming from. So in this case, the model says 75% of the bookings are just coming from baseline. Like we wouldn't have to do any marketing at all, and we would still get 75% of the bookings. Then there's 6.5% from organic channels. This could be, say, email, for example. And then it ranks the contributions by each of these different channels. I mean, here they just use channel 4, channel 3, channel 0, but this could be, social media. It could be TV ads. It could be billboards. And again, there are these really interesting visualizations. So you can see ROI versus effectiveness. Now, this is kind of interesting because you could have a channel that has high ROI but low effectiveness. If, for example, it's just such a small niche little community that maybe it has a high ROI, but you're just not really getting any viewers. And so from a total business standpoint, even with high ROI, you can't really scale because there's just not much of an audience for it. Yeah, you can imagine you had ads that were specifically targeting people who were 6'7" or taller, right? This may have a great ROI because they can't believe, wow, we're getting targeted. This is perfect for people 6'7" or taller. But if you have a general clothing brand, maybe that niche is so tiny that it's just not going to drive a lot of your bookings, even if there could be high ROI. And then the model also provides your ROI with a credible interval that's just similar to a confidence interval, but using Bayesian statistics. But then here's something that marketers really love. And as a data scientist, you're always being judged by what are your recommendations? And so the model, because it's saying which marketing channels are better than others, it's arguing like you can reallocate some of your budget to the more effective channels. And if you do that, you'll end up with more revenue. And in this example, they're saying you could get an increase of about $3 million in revenue if they had reallocated the budget effectively. And they give you specific recommendations. So they would say channel 4, which had that really high ROI, you should increase that budget by 14 million. But channel 3, which had really low ROI, you would reduce it by 24 million. And it even gives these very specific. So channel 3, right now it has you at 40% spend, but optimized, it should only be 29% of budget. But channel 4 is right now 22% of budget, and it should go up to 28% of budget. Now, here's the thing. MMM purports to solve this incredibly complicated problem, but it's not clear that it actually solves the endogeneity issue or the multicolinearity issue. And so in future videos, I'm going to generate some of my own data so we know the true relationships with these variables, and I'm going to put Google Meridian to the test. So follow along and help yourself get a better intuition of what these models can do.